we have a scaling triangle with circumcenter O and incenter I, and we draw the 3x circles. So I think I am going to, oh, actually, we don't really need to draw the x circles. We just need to draw the tangency points of them. So basically, so let's draw these 3 points and reflect them about the midpoints. All right, that looks decent. So this is going to be A1, B1, and C1. All right. This is A1, B1, and C1. Then we draw the orthocenter of A1, B1, C1. I don't think I've ever seen that before. So we have this triangle right here, and we draw its orthocenter, which is probably going to be
It's
far
A, B1, C1.
Oh, you're right. A, B1, C1. Oh, I gotta put commas after each one. Okay. And then M is the midpoint of PA1. Then we want to show HM and OI are parallel. So we need to draw H. What? Why doesn't it? Why does it? Oh, because there must have been already another H. Yeah, this. Okay. I gotta rename this. That's H. And then we draw the circumcenter. Center O. Saying HM and OI are parallel. It's very interesting. All right. Now it's the midpoint of PA1. So we have, these are like the midpoints. P is, so P and H are orthocenters of different triangles. Where's L? I don't even know what L is. Let's see. L is the midpoint of AB. And what's J? J is the midpoint of F. What's F? AB. So L and J are like the same thing. That's weird. Yeah, I just don't need L. Okay. So I wonder, I think, is A C1A B1 cyclic? No. But like I wonder if we want to draw this. And then like P, this segment is double and this segment is double. I don't know if that helps. But yeah, this is a very strange problem. PH is the Steiner line. What is the Steiner line? I should know this, but let's see. Oh, so by definition, it's just the definition. Okay. BC1 equals B1C. Oh yeah, because AE equals AF. So yeah, BC1 equals B1C. And it's perpendicular to the Gauss line of that quadrilateral. So interesting. So if we draw these two midpoints, then we're saying PH is perpendicular to LN. And that looks true. That's interesting. Okay, I'm going to delete these three segments. I don't think we need them.
Looks like PH is parallel to AI.
Really? Interesting. I would not have expected that. So it looks like PH is parallel to OI. And we want to show, oh, were we thinking PH was perpendicular to LN? Yes. OP. And we want to show that HM is parallel to OI. This is really interesting. I wonder if that's an angle chase. Well, no, it wouldn't be that easy. A1, B1, C1 meet at the Nagel point. That one I know. You mean A1, B1, C1 meet at it. Yeah. Oh. So like are you saying it's in center of this triangle? I didn't know that. Okay, hold on one second. So this is the Noggle point, I think is how you pronounce it, something like that. Q would be the Noggle point. And Q to draw the circumcenter of that triangle. Okay. Oh, I don't need this. I can just do this. Is it H? Oh, yeah, H is the circumcenter. Yeah. That's my favorite proof that the orthocenter exists in the first place. QH is parallel to OI. So okay, so the problem is equivalent to showing Q, M, and H are collinear. Yeah. So by homothety, since because Q is the in-center. Okay. I didn't know that Q was the in-center of RST. I never knew that fact. That's interesting. So yeah, you're saying each one is like the circumcenter and the incenter of a corresponding triangle. HQ bisects PA1. We want to. Why is that true? That HQ bisects PA1? Or are you saying the other thing is well known? Oh, that the noggle point is the incenter. That's well known. Okay, yeah. All right. This is a fun problem. So yeah, H, M, and Q. That's what we want to show our collinear. Yeah, I'm not sure what to do from here. So we want to show H, M, and Q are collinear. For Q is the intersection of those diagonals. Can we use? Yeah, the way M is defined is tricky. The midpoint of PA1, where P is the orthocenter. And we said PH is perpendicular to NL. So, how do you know that PH is parallel to AI? I know Stefan said he saw it, but can you prove that? We have shown LN is perpendicular to AI. It won't be that hard. Okay, because we showed PH, yeah. The nasal centroid and incenter are collinear. So, yeah, and that would be like the center of homopathy of the incircle here and yeah, the incircle of RST. So we could use that. Like we're saying that these. Wait, I messed up somewhere. This, and this. Oh, not F. Sorry, it did the wrong point. I need J, C, and I. IQ. Yeah, reflect H across M. Oh, whoops, that's midpoint, not reflection. So that's H prime. A1 H prime is parallel to AI. Why is that? So then we have, because we know pH is parallel. Okay. We have that parallelogram. Yeah, we have to use somewhere. So we know pH is parallel to AI. We have to use somewhere that P is the orthocenter of A, B1, C1. Because yeah, it's basically like, yeah, there's infinitely many points that are parallel to AI on this line. We need to use that P is that point. Yeah. But it's definitely a step in the right. Yeah, it's definitely useful that pH is parallel to AI. What if we reflect P about B1, C1? So it would lie on this circle. I wonder what the center of the circle is. U. Hmm. Um, yeah, is there some other homothety we could use? So P is the orthocenter of this. Can- All right, you guys want to work on this for like 10 more minutes and then move on to another? Okay. Yeah, it is. Yeah. Let's see. You don't like it? All right, a couple more minutes and then we'll move on. Yeah, point P is just the really tricky part. Like how do you use that? We know pH is parallel to AI, but do we use that the reflection of P over B1C1 lies on the circle? Do we use, yeah, what other property of orthocenters do we use? I know there's a lot of like double orthocenter lemmas. I just don't remember. I feel like there's a couple different lemmas where you have like two different orthocenters. I just don't remember what they are. All right, let's try another problem. So, this one, let's see. So we have a triangle with orthocenter H. So this is kind of a problem where you move a point around and this is like a locus problem. Okay, so this is D, and it's H. Then we draw the circle BHD and CHD. That's interesting. Okay, so BHD and CHD. So we want to see where BHD meets AB and where CHD meets AC. Is there a way we can make it so, like, maybe it's nicer if B is on the bottom? Yeah. Okay. So this is P and this is Q. And we're saying the reflection of D over PQ also what? Oh, it looks like those are collinear. That's probably just an angle chase, right? And so we're saying as we move D around, that is a circle. And why does it disappear? Oh, because I made P and Q have to be on the circle itself. That's why. But basically, they're saying that trace out a circle. So first of all, is it obvious PH and Q are collinear? Let's think about that. We want to show that yeah, because PHD is 180 minus PBD, and QHD is 180 minus QCD, and those add up to 180. So that's obvious. Yes. All right. So yeah, what can we say about this circle? Like, what is the center of it? Center would be like right here around. Wonder if we can guess what the center is. Yeah, it seems very random, this circle. I wonder if we take the center of this circle and reflect it across. Yeah, but the line PQ keeps changing, that's the thing. So how would we know where the center is? Oh, maybe we could say something about this point right here, like where it crosses. So it crosses like right here. Is there anything special about that? Uh, so what is the can we use some kind of anti-Steiner point thing? So like this is a line through the orthocenter. And if we reflect it across each of the three sides, intersection is Q point. Okay, that's where the this point right here is the Q point, is what you're saying. Okay, so interesting. And yeah, and now that you say that, I see why it's true, because this this passes through the midpoint of BC. That's well known. And so this occurs. Let's think about that. I thought I realized it, but maybe it's not that obvious. Were you able to prove that it's the Q point, or it's just something you noticed? Okay. One second, guys. All right, I am back. Okay. So if one intersection is a Q point, I wonder what the other intersection is. Is it A? Okay. And it's A, 1B. Let's think about that. So yeah, if the other point is A, then we should probably reflect A across PQ. So in that case, what if we have BHA prime and CHA prime? No, that doesn't do much. What was I thinking? So oh, because PQ is going to shift. I keep forgetting. So we have some circle through A and F. Yeah, we should be able to know what D is when it's this point. So let's try this. We take this line and we reflect about this line. I was going to see if it pass through D. It does not. Hmm. These problems are harder than they look. Just need to find the center of it. Center is, it lies on the perpendicular bisector of AO. It's like right about there. What is that mysterious point? That is the center of this circle. It's like right about here. And I don't know why it keeps saying there's like a new message in the chat, but last one I think is what Stefan sent. It's weird. I keep thinking someone posted something new in the chat. It keeps like saying it, but no one has. It's gonna drive me crazy. I don't know if you guys are trying to tell me something or not. Could it be this point? No. It's gonna say this one, but it's farther away than that. Okay, now I see 4 things in the chat. Ravi said to draw the center of the circle. The locus of the center of the circle. So it's DFA prime, D prime FA. Or what's TFA or so yeah, I'm not sure how to draw the locus. Like I could just pick random points here, but it's just like an estimate, right? So this. Okay. So yeah. D prime FA. Sorry, I was slow. Should have been obvious. Okay. So I is the center. And what can we say about I? Is it tangent? No, that's not tangent to that circle. Yeah, we just have to find something special about point I. IA equals OH, where O is the circumcenter. That is quite interesting. So this might be a parallelogram then? Maybe. Let's see. Because E is the midpoint of AH. Yeah, it looks like it. So I is a reflection of O across E. So that is very interesting. So what do we get when we reflect that circle across PQ? AI is parallel to OH. Are there any degenerate cases that we can show this for? Like this. Okay, so this would be where we take where OH meets sides, and then we draw the circles. Okay, so this case is trivial. Like you let OH meet A, B, and C, D at P and Q, and then you draw in these circles, and you show this is isosceles, and then it's true. Basically, we need to show, I mean, one way to think about it is drop a perpendicular from D to PQ and see where it intersects the circle, and then we want to show that that's isosceles. That's one way to do it. Oh, is D prime D F H cyclic? Yes. I think this might be the key. Okay. So basically, wherever D is, we draw the circle FHD, and we let it intersect at D prime, and then we want to show that D prime is actually the reflection. I like that. I think that is a good idea. Okay. Just gonna make this look a little better. Okay, so we draw the circumcircle of FHD, and we let it intersect this circle at D prime, and then we want to show D prime is actually the reflection of D. I think that seems like a decent idea. So I wonder if we draw this point right here. Oh, FH and A are collinear with the midpoint of this arc. That looks useful. Okay. And this would have to be an angle bisector. I feel like we're really close then. So yeah, once you draw the midpoint of this arc, if you know these are collinear, it's like Robbie's coming back on. Hey, Robbie. So I think we're really close here. I think. Basically, like I saw that D prime FHD is cyclic. I'm not sure why yet. And not only that, if you draw the midpoint of our DD prime, then AF and that point are collinear. Yeah. Is J the center? I don't think J is the center. Let's make sure though. Yeah, it's not the center. So can we calculate angle? So if we let AF, we could let AF meet the circle at K. It's really just a matter of how we define things. Then we want to show that K is the midpoint of D prime. Can we do some kind of, and that these are linear? So this angle maybe we could even use harmonics because we want to show that FD, FD prime, FK, and FG are harmonic. That might be the best way to go, actually. What could we project that onto? We could try projecting it onto the circle. So it's the same as saying, or this circle. I mean, we want to show that LAF, oh wait, I'm getting confused. LFDG is harmonic. That's what we want to show. Is that the best circle to do it on? You know what? Maybe it's better to project this onto this circle up here. So we want to show AD and these 2 points are harmonic. And oh, you know what? And this point, these are collinear. These concur on the circle. So we want to show that AD prime, the antipode of A, so we want to show that these are reflections, R and then also, okay, I was going to say that might be asking for too much. I think R and D prime are like reflections over AN. So yeah. Oh, you have a solution. Okay. So yeah, tell us your solution. Oh, I wonder if F is the midpoint of RD. No. Okay, so I'm going to delete a bunch of stuff I added. So draw the parallelogram OHD prime X. Okay. Should I delete should I delete this circle right here? Okay. Let's delete a bunch of stuff first. Let's make it look cleaner. Delete. Delete this. Okay. Okay. OHD prime X. Let me get rid of the trace. This is driving me crazy. All right. So let's draw that. So I'm going to draw the midpoint of this and reflect. Okay. Whoops. Yeah. And we can hide this. And we can call this X. All right. So we have OHD prime X. Is that right? That should be. Yeah, that's a parallelogram. All right. We can prove AOX equals ODH. Okay, so AOX is the angle that AO makes with HD prime. Is OX is parallel to HD prime. HD prime and DH reflect over PQ. So yeah, okay, so we can calculate that using just angles. And then ODH How do we find angle ODH? Because is AO perpendicular to PQ? Yeah, that okay, because AO is perpendicular. Is that actually true? Okay, so that explains it. The angle that DO makes with DH. Okay. All right, I like that. So that okay, so is that, let's see. So so AOX is equal to ODH. So we have this. Yeah. All right. Whoops. See if that works. Okay. So let's assume that's true. I could type it up better later. From here it follows. Okay. All right. We split it up. So the angle DO makes with DB. Then we have the angle that OA makes with PQ plus the angle PQ makes with H D prime. So this angle plus that angle. And then we have okay. I'll just say with some more calculation, angle AOX equals angle ODH. Then we have OX equals HD prime equals HD. All right. OA equals OD. Okay, so OXA and OHD are congruent. All right. So OXA is congruent to OHD. And basically from there, like D prime is a reflection of O across the midpoint of XH. And X is basically, so XA equals OH. All right. OXA DHO. Okay. Oh yeah, I was gonna say. So AOHY. Interesting. Okay. So I can just reflect. That's Y. Vector AY equals OH equals D prime X. So yeah, that's a parallelogram right there. Yes. Oh, rhombus. Yeah, it has an M. All right, see you next time, Stefan. Have a good one. Okay, so Y is fixed because that's a rhombus. So okay. So we can exactly describe a circle. I like that. But wait a sec. Y is fixed. because vector AY equals vector OH. Yeah. So D lies on the fixed circle Y with center Y and radius OH. That's very clever. Yeah, it's a nice solution. All right, so we have time for one more problem. Yeah, so a lot of parallelograms here. A, Y, B prime X. XD prime equals X. OH, XD prime equals O, this should be YA. And so we said it's a rhombus. OH. Oh, but we said, oh no, it is XA. Yeah, from that part. That's right. Okay. Interesting. So yeah, that congruent triangle is key. All right, so there was, I think, one. I think this is a pretty easy problem, so we could probably do this in 15 minutes. We have a triangle ABC with in center I. And we draw the circumcircle, and it intersects it at S. So S is the midpoint of BC. And then J is a reflection of I with respect to BC. Oops. J. So this is S. And suppose that SJ intersects the circle at P. And we want to show AI equals PI. So maybe some of you have already seen this before. I don't know if I've seen it. So yeah, those are reflections. And we want to show AI equals PI. Is it obvious? I don't know. Right? It seems like it should be like a well-known fact or something. But I'm not sure. So another way we could draw the center of this, it's the same as saying OI is perpendicular to AP. So what we could do instead is we could let P prime be the reflection of A over OI. And then we could show that P prime equals P. It's equivalent to showing, yeah, the reflection of A over OI, yeah. So, yeah, we could call this P prime, and then we could hide this. So if you reflect A over OI, then we want to show SJ passes through it. Is there anything special, about the reflection of A over OI? I'm not sure. I feel like there's got to be some kind of cyclic quadrilateral somewhere. Maybe this? No. But yeah, this looks very familiar, this kind of problem. Maybe it's worth trying this. So this circle is congruent to this one. IOPS prime. Oh, IOPS prime is cyclic, or IOP prime S is cyclic. Sorry, I missed your comment earlier. Like, I knew there was some cyclic quadrilateral. Because IP prime O equals IAO equals ISO. Ah, that's awesome. All right. So we have a cyclic quadrilateral, and then, okay, I feel like we're close then. So yeah, if we define P the original way, and we can show that IOSP is cyclic, then that would solve it. It's a good way to do that. So we know ASP is ISJ. I feel like we're close here. We know this is cyclic, and we have to show P, J, and S are collinear. Maybe we could use medians or semedians. You know what? Maybe it's worth reflecting I over S, because then that would give us diameter. Oops, not the midpoint. I want to reflect. So we get I prime. And we want to show SJ and P are collinear. Maybe that's not such a valuable point. All right, 3 more minutes and then we'll hop off. So actually, you know what? The orthocenter, so J is the orthocenter of this triangle, right? J is the orthocenter of this. And I feel like that might be useful. So we have a triangle. Maybe we can think about it in terms of triangle ABC. So S is the center of that circle. J is the orthocenter. So we want to show the center, the orthocenter, and some other point are collinear. And we know that OH so this is the Euler line. We want to show P lies on the Euler line of this triangle, or P prime. Seems like it should be easy, but I don't know. I wonder if these triangles are congruent right here. IOP prime and what was I thinking? Is this a parallelogram right here? No, I don't think so. All right, so I think we got pretty close on this one, but I am going to stop here because it's noon. But thanks everyone for staying on. I appreciate it, and for all these fantastic solutions. This was a really fun session. So I'll see you next time. And for any of you watching, if you want to join us on the next session, feel free to email me at mgreenbeat01@gmail.com. It's in the description of my video. So thanks again and have a great day.